Excavation is an awesome place to be because that means you get to actually get started. Maybe you've put in a bunch of legwork doing drawings or getting permits if you needed them, and now you get to start actually doing something, right? And it's really exciting as an inspector. I've got 2 or 3 projects going on in my area right now where homeowners are putting additions on their house, building a garage, and it's cool because it's something to be proud of. It adds equity to your property, and maybe you got a growing family and you need a couple extra bedrooms, and so it's just helping provide that space. So it's really fun to help out with that. So for excavation, to start with, right out the gate, I'm going to dive into some pictures and then we'll dive into some code, so you kind of know where I'm pulling everything from. But the biggest thing you think of is below frost line and native undisturbed soil. Those are like the 2 biggest things that you got to think of when you start digging holes. Frost line, it changes, right? It just depends on where you live and what the weather's like. But the code book is going to tell you that you're supposed to be a minimum of 12 inches below grade. So grade would be top of soil. You need to be 12 inches below that. Now where I'm at, our frost line is 2 feet below grade. So all of my footings where I'm at have to be 2 feet below top of soil. If you live in like Maine or Wisconsin, it might be more than that. I know the county above where we're at, it's 30 inches instead of 2 feet. But if you're down south, Arizona's, Texas, those areas, there might not be any requirement for frost because it doesn't really freeze. So then the minimum would be that 12 inches. But then the other part of that is native undisturbed soil. If you're only digging down 12 inches, maybe there was some fill brought in or some debris that you found and it has been there for a while, but it's still fill material. You want to make sure you get below that. The last thing that you want to see is to go build this beautiful addition, but you put it on some type of fill material and it settles even 1/8 of an inch or 1/4 of an inch. Well, you can imagine, drywall doesn't just, expand and contract 1/8 of an inch, so it's going to crack. If you get cracks in your foundation from movement, you can get moisture penetrations. So it can be a big deal. You want to make sure you're on that native undisturbed soil. So those are 2 big things when it comes to excavation. Figure out your frost depth or your minimum excavation depth that's required from your local building department, and make sure you're not on fill. Call before you dig. That's another thing that I just want to always tell people, at least where we're at, it's a free phone call for homeowners. Hey, I'm going to be digging in my backyard in a few days, or on my side yard, or I'm putting a shop in the back. I just want to make sure I don't have any utilities that I'm going to dig up. Just make sure you're covered and protected. Right? The last thing you want to do is rip up your cable line and then, you got to wait weeks to have someone come out and fix it. Those right there would kind of be that's the big kind of 3 when it comes to starting to dig. So now we're going to pull ourselves up and get into like drainage, right? So we've dug down. Now we got to figure out, how high is our wall? Well, our top of wall might be set for us. If you're doing an addition on your house, you want the top of wall to be exactly the same. That's simple. That's good to go. Just match them up and you should be just fine. Maybe it's a garage, or maybe it's a standalone carport, or like a man cave or a she shed or something like that, and it stands alone. So then now you got to figure out, how high do I want this thing out of the ground? I mean, if it's a garage, I don't want my driveway to be too steep, but I don't want it to be too shallow. I also want to make sure that I'm not draining into my neighbor's property, but I'm not draining back into my foundation. So those are all things you got to kind of think about when you're setting your wall height. So how high is the top of your foundation wall above your soils? And how do your soils land? Maybe there's a huge steep slope that goes off to one side. Maybe you have to make sure that you kind of have your slope goes front to back with your drainage instead of off, right? You don't want to slope off into your neighbor, but it's steep. So now you got to make sure that maybe your slope back to the road where your driveway starts, something like that. So those are things you want to think about when it comes to drainage. don't drain onto your neighbor's property. Don't drain back into your building, your foundation, right? And you want to keep all of your drainage on your property. Those are huge, okay? So when you're thinking about, okay, I got my frost depth, I'm not draining on my neighbor's property, I'm not draining back into the foundation, you know, those are all things to think about. So then it's like, okay, well, what about separation from woods? Most people use wood, right, for their construction. It's usually the cheapest form of material, and pretty much, anybody with a few tools can do some framing and put it together. And well, wood decays, so you have to have separation from earth, which can have moisture in it or snow buildup or whatever you have going on. And that big number is 6 inches. That's kind of the number you want to think about. So when you're thinking about top of wall, and you're thinking about your soils being at least 6 inches down. If it's a little more, that's awesome, but you want to keep that 6-inch separation from top of foundation wall. So that will also cue in all your drainage around your building, and it's going to cue in how deep you're going to go, because if your grade is here and you're going to be 6 inches up, and you're going to go down, in my case, 2 feet, well then I need at least a 6-inch footing and a 2-foot wall, because I need to be 6 inches down, and then I need 2 feet of frost depth. So hopefully that kind of will help you work through just when you're trying to design how deep you need to go, your layout, and all that kind of stuff. So let's look at some pictures, and then I'll dive into the code book a little bit. This right here is a new house. And so they've dug down, it's ready for the footing forms to be put in. They've already run the sewer line. Here's the water line that's sticking up through it. And so they have excavated. You can see here that it's, at least 2 feet, right, worth of grade here. And it gets a little thinner here, but they're going to bring in, when they excavate and they backfill, they're going to make sure that they bring in some soil so that they have their 2 feet of frost coverage. And then they'll have a nice slope here from the approach from the sidewalk up to the garage. So that would be, that's a nice clean excavation. When you're in the back of your house, you don't have a lot of room, or you're going to put all this dirt you're digging up. I get it. Just make sure the bottom of your footing is overdug so that you have room to work when you're building your footing. And also make sure it's nice and as flat as you can get it and as undisturbed as you can get it. Here is an example of a footing that's all set up, and this is one of the houses where people are putting an addition on their house. They have a standard, split level type house, and they're going to do an addition on one side, so they have some additional space in the basement area or the bottom of the split level, and then another section up above. So they can add a bedroom, and then maybe they're making their living room and kitchen bigger. And so their top of wall is just going to be right here. It's going to be the top of this existing foundation wall. And they dug down to their footing. I don't know if you can see it very well, but the footing right here, so they essentially are just matching what's there. And they built this footing in here. They dug it all out. And you can see right here, this is a gas line. So hopefully they called before they dug. If they would have hit that gas line, that would have been a bad situation, right? You would have had to call the utilities and to stop everything. As you see here, barely see it right here. Here's their gas meter. But anyways, you can see that this is definitely at least 2 feet deep from where I'm at. Now, if your existing foundation is only 12 inches below grade because you live in a warmer climate, maybe you just match that and you just dig it around. You make sure it's all native soil, and it's not that big a deal. And if you're only 12 inches, you might not even need to do a foundation wall. Maybe you just do a nice big thick footing, and that's all you need. And then you frame on top of that, and you're good to go. Here's another picture of it. So you can see, coming from this angle, they've got their footing set. They're definitely 2 feet below grade, right? And it's snowy where we're at, or was. It's starting to melt, but here's a foundation where they've stepped it. So it's another thing to take into account. Maybe you do have some soils that aren't very good. Well, you can dig on your undisturbed soils that are clean at whatever the minimum is, and then just step your footings and your foundation wall down. Save yourself the money. There's no need to pour a big old wall or a whole bunch of concrete if you don't need to. So here you can see that they have here's their footing, here's their foundation wall, but they've stepped it right here. And then I think they stepped it again. So they're working their way down the hill. Maybe you're on a hill and you want to step you can see right here, they've stepped and then they stepped again, right? They're just saving themselves a bunch of material, because otherwise, they would have had to have dug this whole thing that deep, but they stepped it up, kind of following the grade. So hopefully that kind of helps make sense on excavation, right? Dig yourself down, pretty simple, right? Just those couple little things to think about. Drainage, right? Just make sure you're not draining on your neighbor's property. You don't want to make them mad, and you obviously don't want to drain back into your house. No fun. Or back into your addition or your garage. Maybe you've got a workshop in there, and the last thing you want is water flowing into your garage floor while you're trying to work on your car or something. And then now we're getting into like separations, right? We talked about that 6 inches from earth to wood, okay? And that would be the same thing that would kick into play when it comes to like posts, structural items like floors and glulam beams are even a little bit more. They're 12 to 18 inches. So that's another thing to think about is, well, okay, I'm going to pour, my footing only has to be 12 inches below grade. But then the code book says, well, any glulam beams or any structural beams or girders have to be 18 inches from earth. Okay, well, then that means that maybe you're doing a floor system, and in your crawl space, you're doing like a post to beam type thing where you have a spot for your floor joist to sit over the top of a beam. Well, that beam's supposed to be at least 18 inches above grade unless you put in treated material. So that's where the kicker starts to come in, right? It's like, okay, 6 inches earth to wood. If you remember that across the board, 6 inches earth to wood, but then you just make sure that anything that's within 12 inches of ground is treated, then you should be fine when it comes to structural floors and glulams. Same thing with posts. Posts are going to be 6 inches. So if you have a pier, right, you have a pier for a deck, and that pier sits 6 inches above earth, well, then you can just use a standard post. If you're going to get any closer than that, it should be treated. In my opinion, anytime you're near the ground, I would put in treated anyways. But per the code, depending on cost and what your budget is, maybe you don't want to put in treated posts. Well, just make sure to pour your pier footing up 6 inches above the ground, minimum, and you should be fine. So let's look at a few more pictures. So here's like a deck, and you can see treated posts. Obviously, this beam is well over 18 inches, and so are these the deck joists, so they don't need to be treated. But these posts are, because they're definitely within 6 inches of the ground. You can also see this existing footing or existing foundation wall, and making sure that you're 6 inches from earth to wood. So from this point, so they're going to need to do a little bit of grading right here just to pull some of this dirt away from the house, so that you got that 6 inches. You also are going to want to make sure that you set yourself up, if you're doing a slab on grade, to make sure that you get your insulation put in there. So let's go to the code references. So here are the requirements. So for foundation construction, it says fill soils that support footings and foundations shall be designed, installed, and tested in accordance with an accepted engineering practice. That just goes right back to the whole undisturbed soils, right? Undisturbed soils. If it's fill, if you found out that it's fill, it's got debris in it, you moved it in it recently, it has not been there long enough to be considered native, well then you would have to get an engineer and like a third-party compaction test. That's why most homeowners just dig down as far as they can and get to that native soil. Here they're talking about fall. So surface drainage shall be diverted to a storm sewer conveyance or other approved point of collection that does not create a hazard, right? So here they're talking about lots shall be graded, drainage surface water away from foundation walls, kind of like I talked about. And here they're actually telling you that you need to have a grade that shall fall not fewer than 6 inches within the first 10 feet. Well, most people, you know, their property line might be, their building might only be 5 feet off the property line. You don't have 10 feet, which is kind of this exception that they talk about right here. At the end of the day, as an inspector though, if it drains away, it's good. I don't get out there with a tape measure and make sure that the idea is drains away from the building and not on your neighbor's property. Here's frost protection. So here's minimum depth. So the exterior footing shall be placed not less than 12 inches below undisturbed ground surface. So there's that minimum, right? If you're in the warmer climates, they're still going to ask you to put your footings 12 inches below grade. Frost protection. So except where otherwise protected from frost, foundation walls, piers, and other permanent supports for buildings or structures shall be protected from frost. So again, let's just make sure you're below your frost line. You know, here are some of the following methods. It says extend below the frost line. One of the exceptions is if you're on solid rock, right? You dig down and you're like, man, this is solid. There's no dirt to go. There's no moving. There's nothing you can do. You dig down, you get to that solid rock. Sometimes inspectors might ask you to pin. So roto hammer down into the rock and actually set rebar in it so that you're pinning your foundation to it. I would definitely check with your building inspector when you get it dug and make sure they're okay with whatever avenue you decide to go down. It says footing shall not bear on frozen soil unless the frozen condition is permanent. And then here's a couple exceptions. If you're doing accessory structures, 600, less than 10 feet in height, you don't have to have that protection, or 400, other than light frame construction. Now let's talk about separation from the ground. So like I kind of said earlier, 6 inches is the big number, right? You want everything to be, your foundation walls, your piers, everything is 6 inches above grade. And if you can't get to that, well, then you need to use what they call a pressure-treated lumber, pressure-treated wood. And that just says all wood in contact with the ground, embedded in concrete, or in direct contact with the ground, or embedded in concrete exposed to the weather that supports permanent structures, so any type of addition or garage or anything you're doing, intended for human occupancy, shall be approved pressure-treated wood, suitable for ground contact use. It also has in here, it says except that untreated wood used entirely below groundwater level or continuously submerged does not have to be. I don't know why. My assumption is that pressure treated wood has, chemicals in it, and so having it submerged in water may not be the best thing for it. But for the most part, any type of project you guys are going to be doing, just think about pressure treated wood when you get close to the earth, close to the ground, and you should be just fine. So here we have height above finished grade. I talked about 6 inches being the big one, right? Concrete and masonry foundation walls shall extend above the finished grade adjacent to the foundation at all points not less than 4 inches where masonry veneer is used and not less than 6 inches elsewhere. So the only caveat is if you're using masonry veneer, so like a brick veneer on your house, then you can get to within 4. But really the number is 6. Like top of foundation wall to soils, 6 inches. Here we talk about columns. So again, I showed you that picture of that deck. It says wood columns shall be approved wood for natural decay resistance or approved pressure preservative treated wood, right? And here's the exceptions. And here it's just talking about where supported by concrete piers or metal pedestals projecting 1 inch above a concrete floor or 6 inches above exposed earth. So again, there's that 6 inch thing. Pier 6 inches above ground. You don't necessarily need to treat it, though I would. Here it talks specifically about deck posts. So here's that 6 inches above exposed earth. Here we can jump into, this is protection of wood and wood-based products against decay. Protection of wood and wood-based products from decay shall be provided in the following locations by the use of naturally durable wood or wood that is pressure treated. The big one to see is just this first one right here. Wood joists or the bottom of a wood structural floor where closer than 18 inches, So they're saying the joists, if they're within 18 inches of the ground, or wood girders, so we're talking about beams or any type of like support that's holding up that floor, girders, closer than 12 inches to the exposed ground in crawl spaces or unexcavated areas located within the periphery of the building foundation. So they're telling you that if you are above that, you don't need to pressure treat it. But if you're below it, you do. That should cover excavation for the most part. That should cover kind of the base when you get started, right? Which is exciting on pump for you. Below frost level, 12 inches minimum, undisturbed soil, grade away from your building but not onto your neighbor, 6 inches earth to wood, and if you got a crawl space or some type of post beam situation, just make sure you have those separations or use treated lumber.